Hello everyone, welcome back to another lesson. In this lesson we are going to finish limits, evaluating limits, then stay tuned. Previously we solved these questions, so today we directly start with these questions. Okay, question 12. The question says find the indicated limits. Find this limit. If I directly put 5 in place of x, this will be 5 minus 5 over 5 squared minus 25. That's clearly going to be 0 over 0. Then since it's 0 over 0, I can factor this, then remove one of the factors. Later in the next chapter we study a way, it's called L'Hopital. We can solve every limit that becomes 0 over 0 within 2 easy steps. Now look at this, how can we solve this without the idea of L'Hopital? Here, this x squared minus 25, it's difference of 2 squares. It's going to be x minus 5, x minus 5, x plus 5. Then these two will cancel out. What's remaining is 1 over x plus 5. Now if we replace (1 over x plus 5), if we replace x with 5, the answer is 1 over 10. Then this is the answer of the limit. This one, x squared minus 5x plus 4, if we directly put 4, we will get 0. And if we put 4 here, we will get 0. Again, we need to get rid of this factor that makes it 0. Then as I said, later we study a way that we don't need to do these, but as information, you need to see how can we factor these. Then look at this one. X squared minus 5x plus 4. I need two numbers. When I multiply, I get positive 4, and when I add, I get negative 5. That's x minus 1 and x minus 4. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. Then here, again, I need two numbers. When I multiply, I should get negative 8. Then it's about x minus 4 and x plus 2. Negative 4 times positive 2 is negative 8. Negative 4 plus positive 2 is negative 2. Now these two factors cancel out. What's remaining is x minus 1, x plus 2. If I put 4 in place of x, this will be 4 minus 1, 3. 4 plus 2 is 6. 3 over 6 or 1 over 2 or 0.5. These are all correct answers. This one, if I put 4, this will be 4 minus 4, that's 0. If I put 4 in place of this x, 4 plus 5, 9. Square root of 9 is 3, and then 3 minus 3. This will be 0 over 0. To get rid of this square root, I should multiply up and down by the conjugate of this root, which is square root x plus 5 plus 3. And down the same thing, square root x plus 5 plus 3. Now if I do this multiplication, square root x plus 5 times square root x plus 5, it's multiplication. This will be just x plus 5. 3 times negative 3 is negative 9. Over, down is the same. I just write the same. X minus 4 multiplied by square root x plus 5 plus 3. Now, x plus 5 minus 9 is equal to x minus 4. X minus 4 cancels x minus 4. So this is going to be x minus 4 up. And down we already have x minus 4 and this factor. X plus 5 plus 3. These two cancel out. What's remaining at the end is 1 over this. Now if I replace x by 4, 4 plus 5, 9. Square root of 9 is 3. 3 plus 3, 6. 1 over 6 is the answer. The result of the limit of question 14 is 1 over 6. Now, question 15. If I directly put 0 in place of x, this will be 1 over 4 minus 1 over 4, that's 0. Over 0, again, it's 0 over 0. The way we study later, we use derivatives to find the limits, but some functions like this, their derivatives are not easy. Then it's better to learn the actual way, the better way for such questions. But questions like this, later we use derivatives. It's easy to find derivative of this. It's easy to find derivative. These ones as well. But questions like this, we still have to go back to this way that we are doing right now. Now, let's do question 15. This question 15, as I tried, if I put 0 in place of x, I'll get 0 over 0. Now, these two fractions, x plus 4 minus 1 over 4, since I have two fractions, between them is minus, I should find the common denominator. Then here we can apply butterfly method. 4 times 1. We multiply 4 by up and down, so it will be 4x plus 4. Minus, we multiply x plus 4 here by up and down. Then it will be x plus 4 over 4, x plus 4. Now I have two fractions. Between them is minus. I can manually subtract. That's 4 minus 4. Or we can write this as one fraction. It's going to be 4 minus. This minus is for both. It will be minus x minus 4. 4 minus x minus 4 over the same denominator, x plus 4. All right. 4 minus 4, that's 0. Then what's remaining is negative x over x plus 4. X cancels x, that is negative 1 over x plus 4. If I replace x with 0 this time, x tends to 0, replace x with 0, we will get this, negative 1 over 0 plus 4, 4. The answer is negative 1 over 4, or the answer is negative 0.25. These are the answers. For questions 16, 17, such questions, delta x tends to 0. If I put 0 in place of delta x here, it will be x. With this power 2, x power 2. X power 2 minus x power 2 is 0. And instead of delta x, we have 0. This will be 0 over 0. Then for cases like this, when there is a bracket with power, it's better to expand the bracket, then do the necessary simplifications. Later, we can do the limit easier. This x plus delta x, there are two ways to expand. The manual way, to avoid mistakes, you can write the bracket twice. X plus delta x. Write the bracket, because it's power 2, we write the bracket twice. Then manually multiply. Or you can say term 1 squared. Term 1 squared is x squared. 2 times first times second. So 2x delta x. Delta x is different from x. I cannot say 2 delta x power 2. That's a very common mistake. If someone writes 2 delta x power 2. This is wrong, because x is a different thing. Delta x is another thing. We cannot combine them. It's just like AB. A multiplied by B will be AB. We cannot mix them. Then same thing is applying here. That's a very common mistake. Avoid this, dear students. And delta x power 2, it will be delta x power 2. There is minus x squared, right? Minus x squared. These is all over delta x. So if we erase these, and write the denominator, It's all over delta x. All right. Now, we have like terms. There is x power 2, and there is negative x power 2. So they can cancel out x power 2 and negative x power 2. What's remaining is 2x delta x plus delta x power 2. From the remaining terms, I can take delta x as common factor. So it will look like this. Delta x. What's remaining here is 2x plus that's delta x power 2. Delta x remains all over delta x. We did all of these simplifications to see this. Why? This will cancel this. We will end up having only 2x plus delta x. Now we replace delta x with 0. The final answer is 2x. Final answer is, if we make this limit, delta x tends to 0. So result of this is just 2x. We replace delta x with 0. So no change happens to x. It stays as it is. This is the answer. There is a fast way. For now, you might not understand this fast way because we didn't study derivatives yet. But when we study derivatives, I'm sure you will understand. When you see limits in this form, limit delta x approaches 0. Here we have a bracket with powers, and here we have minus x squared. Ignore the minus. X squared is the function. What's the derivative of x squared? 2x. See, that's the same answer. So if we apply the fast way for this one, negative x power 3, this is the function. Ignore negative x power 3. If we find derivative of this, it will be 3x power 2. Then the answer of this limit is 3x power 2 if we use the derivative way, or we can use the manual way, expand the brackets. There will be x power 3, there is minus x power 3, they cancel out each other. Take delta x as common factor, then from what's remaining, replace delta x with 0. You'll get the answer, and the answer should be 3x power 2 for this question. One important thing about this question, how can we expand brackets with power 3? If I really had to expand this with power 3, how can I expand this? To expand this, we write a small bracket and a big bracket. The small bracket is the same, x plus delta x, that's it. The big bracket, first term power 2, minus first times second x delta x plus second power 2 delta x squared. Now this is the expansion. We can multiply this x by everything, multiply delta x by everything. Then the expansion for a bracket with x power 3 is long, and later when we simplify, we will have only 4 terms remaining. But the fast way works all the time. It's the best for multiple choice. There are some other questions that using the derivative way that we study later is not very easy. Finding derivative of these takes time, and there is a high chance of making a mistake. Let's just do this with the conjugate way. This one as well. And this one, just like the fractions, since we have 2 fractions, between them is minus, we need to find the common denominators using butterfly method. Here, question 18. We need to multiply up and down by, that's x plus 5 minus square root 5 over x. We need to multiply up and down by square root x plus 5 plus square root 5. This is the conjugate. Minus becomes plus. We write the same thing down. Plus square root 5. Square root 5, square root x plus 5 plus square root 5, these are the same thing. If we simplify this, it's equal to 1. and 1 multiplied by anything stays the same. This is why we do this. This stays the same after this simplification. Now, if we multiply these two, the square root will go away. It will be just x plus 5. And multiply these two. If we multiply two numbers, they both have square root. The square root will be cancelled. What's remaining, positive times negative is negative 5 over x times this. X times square root x plus 5 plus square root 5. Now positive 5, negative 5 cancel. Up, only x remains. And only x will be cancelled with this x. So at the end, we will have limit x tends to 0. Denominator is x plus 5 plus square root 5. And up, nothing remained, means 1. Now if I put 0 here, it will be square root 5 plus square root 5. That's 2 square root 5. Then the final answer is 1 over 2 square root 5. So the final answer of this is 1 over 2 square root 5. This is the given. If the answers in the multiple choice are given in decimals, you can use calculator, make this a decimal, then choose the correct answer. For sine and cosine, we have two very important rules. The sine is like this. Limit x tends to 0. The x should be approaching 0. We don't accept any other number. This rule is only for x tends to 0. Sine x over x is equal to 1. And for cosine, 1 minus cosine x over x, it's equal to 0. Now, look at this. Sine x over 5x. Then since it's limit, I can take this 5 out of the limit. But this 5 is in the denominator. I cannot write 5 outside. Instead, I write 1 over 5 outside. Look at this one. And instead of this 5, I write 1 over 5 outside. Then limit x tends to 0. Sine x over x. I know this limit is equal to 1. This entire limit is equal to 1. 1 times 1 over 5 is 1 over 5. So the final answer is 1 over 5. This one. There's 1 minus cosine x. 1 minus cosine x over x. There's over x. This 3 goes out. This 3 is up. So outside I can write only 3, not 1 over 3. So it will be 3. Then limit x tends to 0. 1 minus cosine x over x. As a rule, this is equal to 0. 0 times 3 is 0. Limit cosine x tan x over x. Okay, I know tan x is sine x over cosine x. Every time I see tan, I can replace it with sine x over cosine x. Now let's replace this tan with sine over cosine and see what's going to happen. It looks like this. Cosine x multiplied by sine x over cosine x, all over x. When you have multi-fractions, make sure to make this, the original fraction, bigger. Now it's clear that this is the bigger fraction. The numerator simplified became this. The denominator is as it is. Now cosine cancels cosine. This means I have only sine x over cosine x left over. And the limit goes to 0. It's just this rule. So this result is equal to 1. More trigonometrics. Here, that is sine squared x. Sine squared x, I can write it as sine x times sine x. Then limit x tends to 0. Instead of sine squared, I write sine x multiplied by sine x over x. Okay. I can make this limit two limits. According to the rule, this part, sine x over x, limit x tends to 0, is equal to 1. So this part is equal to 1. Sine x alone, if I put 0 in place of x, sine of 0 by calculator, it's 0. Then I have 1 times 0. 1 times 0 is 0. Result of this limit in question 24 is 0. Tan squared x over x, let's look at this one. We said tan is sine over cosine. Then let's see. This is going to be sine squared x over cosine squared x over x. This is the original fraction. So make this different. Now up is a fraction, down is not fraction. This is not fraction means it's over 1. Now keep the first fraction, sine squared x over cosine squared x, and flip the other fraction, 1 over x. This one. If I had put 0 in place of x, it would be 0 over 0. Then the way that we study later using derivatives works on these questions as well. Okay, especially for this one, we can do it in this way or the other way that we study later. Here, it's multiplication. Don't confuse. Multiplication, we multiply numerators together, denominators together. So we can write this as this denominator can go there, this one can come here, there is no difference between them. This will be sine x. This is instead of sine squared x over x multiply by 1 over cosine squared x. This part, sine x over x, is equal to 1. Because the limit tends to 0, then sine x over x is 1. Sine of 0 is 0. Now I have 1 times 0 times. If I put 0 inside cosine, cosine of 0 is equal to 1. Power 2, still 1. So I have 1 times 0 times 1. At the end, it's equal to 0. The result of this tan is, the result of this limit, tan squared x over x, is 0. Question 26. Limit x tends to 0, sine 2x over 3x. The answer is directly 2 over 3. Without wasting time, for multiple choice, that's the best thing. Or, if I directly put 0 in place of x, it will be 2 times 0 inside the sine. Sine 2 times 0. This is sine 0, and sine 0 is equal to 0. Up and down will be 0, that's 0 over 0, and later we study the way to do this question. But the answer is 2 over 3. Here is another way of doing limits. It's called sandwich theorem. We use sandwich theorem to find limits of trigonometrics most of the time. How can we set up the sandwich theorem? How can we use it to solve this question? Look at here. Firstly, we begin with cosine 1 over x. Cosine 1 over x. We know sine and cosine, their graphs are from -1 until 1. Like this is the graph of cosine. This graph is from -1 until 1. It cannot be more than 1. It cannot be less than -1. Then I write cosine 1 over x. make sure to write the same angles, because later whatever we do, we cannot change the angle. Then begin with what do we have? 1 over x. I know this cosine is from 1 until -1. It's more than -1. It's less than 1 or equal to. Then this is it. To make this look like this one, we multiply all the 3 terms by x. If we do this, x times -1 is -x, less than equal to x cosine 1 over x, less than equal to x. Now, I do limit x tends to 0 for this function and this function. If the two results of left and right are equal, then we say this limit exists and it's equal to the same result. Now, limit x tends to 0 for x. That's direct substitution, it's equal to 0. Similarly, limit x tends to 0 for negative x is equal to 0. Now, since the upper function and the lower function at 0 have the same limits, then finally, limit x tends to 0 for x cosine 1 over x is equal to 0, just like the two functions. This is the sandwich theorem. Sometimes it's called squeezing theorem. This is the idea. Let's do another example in this regard. Check this out. Limit x tends to 0 for x sine 1 over x. Okay, I know sine 1 over x is less than equal to 1, less than more than or equal to -1. To make this look like x sine 1 over x, multiply everything by x. So it will look like -x less than equal to x sine x less than equal to x. Now if I take the limit of x, fx equal to -x, limit x tends to 0, this limit will be 0. This limit will be 0 as well. This means this limit exists and it's equal to 0. The reason, by sandwich theorem, the left limit, the right limit are equal, then the limit exists and it's equal to the same result as these, which is 0. This question. These questions, students have problem with it because there are letters, especially this one, question 30. But look at here, how can we do this? In question 29, two functions are given. And the question says, use the squeezing theorem. Squeeze theorem is sandwich theorem. Then limit x tends to c. In this question, c is 0. It means find limit we need to find limit x tends to 0 for fx. In order to find this limit, I will do the upper limit and the lower limit, and let's see the result. If I put 0 here in place of x, 4 plus 0 power 2 is equal to 4. That's the upper function. The lower function is 4 minus 0 power 2. If I put 0 in place of x, that's also equal to 0. Then by squeeze theorem, since the upper function and the lower function, they both have limits and both limits are the same, then we say the limit of this function, that we actually don't know the function, but we know lower and upper functions of it, then result is 4, just like these. The idea is we don't work on this directly. We work on the upper function and the lower function. Question 30, this time c goes to a. It means we are dealing with limit x tends to a fx. Fx is the function between this function and this one. To find this result, we need to do this limit, and let's find the result. Here, if I put a in place of x, it will be b minus absolute value a minus a. A minus a is 0. b minus 0 b minus 0 is b. So the limit of this side is b. Limit of the other side, if I put if I put a in place of x, it will be b plus absolute value a minus a. A minus a is 0. So this is a. A minus a is 0. Then b plus 0 is equal to b. Limit of this side exists and it's equal to b. Then we say limit x tends to a for fx is also equal to b. This is the answer of question 30. Here are some good questions at the end of the chapter. Let's look at these. This one is obvious. That's direct substitution. You just put 1 in place of x, then calculate, you get the answer. Question 4, limit x tends to negative 1, and we have this. Let's do this one. Then if we put negative 1 in place of x, it will be like 5 times negative 1 power 2 plus e2 power 2 times negative 1 is negative 2. Negative 1 power 2 is 1. 1 times 5 is 5 plus e negative 2. This is the answer. Or by calculator, you can make this a decimal. E exists in calculator. You can press alpha and the lim button, you can get this, or in the lowest row of the buttons, you can see this E. The value of E is 2.71. E is just a number, just like pi. It has more decimal places, but the shortcut of E is 2.71. We can use it to make this answer decimal. Question 5, this one. Limit x tends to 1. Then if I put 1 here, it will be 0. If I put 1 here, since it's absolute value, we should take left and right. And if we do left and right, the result, let's find it. X squared minus 2x plus 1, this one, we can factor it, or you can use calculator, just put a number in place of x, in place of 1, a very close number to 1, like we can choose 1.01 in place of 1, that's the right limit. Every time for absolute value, we will do left and right. If they are both equal, then the limit exists. If they are not equal, the limit doesn't exist. Here, instead of 1, if we approach this limit on the right side of 1, we can choose like 1.01, put it in place of x, write the result. Then left side of 1 is like 0.0, it's like 0.99. Put the 0.99 in place of x, the results will be the same. Then you can find the limit. This one could be factored. If I directly put 2, it will be 2 power 2, 4 times 2, 8, 8 minus 8, 0. 2 minus 2, 0, it will be 0 over 0. Then we can use the way that we are going to study in the upcoming sessions, or we can factor this and then cancel out. This one, 3x minus sine 2x over 2x minus sine 3x. Let's do this one. If I put 0, it will be 3, 0. 3 times 0 minus sine 2 times 0 is 0. So up is all 0. And if I put 0 here, 2 times 0, 0 minus sine 3 times 0 is also 0. This became 0 over 0. Then we can use L'Hopital rule. Later we study to calculate this limit. For this one, we need to find the common denominator, butterfly method. Write x up and down, write x plus 2 up and down here. add the two fractions, then we can find the limit. The sign is already done here. We can divide up and down by x. Then, according to the rules we know, that will be 2 sine 2x over 2x, so they cancel out. This part will be 1 times 2, 2. According to the rule we know, that is 1. 1 times 2 is 2. Then 3 minus 2 is up. According to the rule we know, this part is equal to 1. 1 times 3 is 3. Then 2 minus 3. Result is negative 1. Here, what happened, when the function has the limit as 0 over 0, we can divide up and down by the highest power of x. Here, the highest power of x is 1. So we divided up by x and we divided down by x. How, you might wonder, how this became this? Since it's one denominator, we can separate the fractions. It will be like 3x over x minus sine 2x over x. X cancels x, only 3 is remaining. Now, the rule we studied, it was like whatever angle we have here inside the sign should be down as well. Now, in order to make this x 2x, I write here 2 and 2 here to keep the balance. Then, as we said, this 2 stays out. This will be 1. 1 times 2, 2. Then 3 minus 2 is 1. 2 minus 3 is negative 1. Do the division, that's negative 1. As I told you, this is not important. The best way is the L'Hopital rule, which we are going to study in the upcoming sessions. In this lesson, we are going to talk about continuous functions and the continuity related questions. Previously, we finished limits, and limits are important for continuity. Here, continuity has 3 main conditions. A continuous function should satisfy all of these 3 conditions. Number 1, the function should be defined. The function should exist at the certain value that we work on. Number 2, the limit should exist. Number 3 is like combining 1 and 2. The limit and the function should be equal. Now, let's look at some cases where functions are not continuous. Here, this function, where x is equal to c, there is no graph. This point is open. When it's open means there is no value. This graph is broken. It's discontinuous. Here, at c, there is a value. It's closed here. But since the graph is 2 pieces, the limit does not exist, then condition 2 will not be satisfied. It is not continuous. Number 3, the value exists, the limit exists, but the limit and the value of the function are not equal, then again it's not continuous. This example, we have 4 functions. Let's discuss the continuity of them. 1 over x. The graph of 1 over x is like this. The graph is like broken at 0. One piece goes up, one piece goes down. Then it is discontinuous at 0. And this discontinuity point is not removable. It means we cannot simplify this fraction to get rid of x. Then it's not removable. Number 2, x squared minus 1 over x minus 1. When I replace x with 1, it will be 1 minus 1, that's 0. Down will be 1 minus 1, 0 over 0 is undefined. This function at 1 is undefined. It means it's not continuous at 1. But this discontinuity point is removable. What do we mean by removable? We can rewrite x squared minus 1 as x minus 1, x plus 1. And down we have x minus 1. X minus 1 cancels x minus 1. What's remaining is only x plus 1. And if we put 1 in place of x here, it will be 2. It's defined, it has no problem. Then this discontinuity point is removable. This is the meaning of it. This piecewise function, when I put 0 in place of x, 0 plus 1 is 1. When I put 0 in place of x in the other piece, it's also 0 power 2, which is 0 plus 1 is 1. Since both values are equal at 0, then it is continuous and it has no problem. Finally, sine x. Sine x, it's known that it's continuous. The graph is like waves repeating over and over. Sine is always continuous. Here we have this question, this example. Is the function continuous at x equal to 1? Let's see. What do we do first? Condition number 1, find f of 1. F of 1, if I put 1 in place of each x, it will be 1 squared minus 3 plus 2. 1 minus 3 is negative 2. 1 minus 3 plus 2. 1 minus 3 plus 2 over 1 minus 1. That's equal to 0 over 0. Since it's 0 over 0, then it does not exist. The function is undefined. This means this function is discontinuous at 1. Then, is this discontinuity point removable? Let's see. Here, x squared minus 3x plus 2, we can factor this to 2 brackets. The brackets, I need 2 numbers to multiply to get positive 2. 2 numbers, the same 2 numbers, if I add, I should get negative 3. The 2 numbers are like this. Negative 2 times negative 1. If I multiply them, it will be positive 2. Negative 2 plus negative 1 is negative 3. So I got the last term, I got the middle term as they are. Then I can use these 2 numbers in the brackets. So I have x minus 2, x minus 1 over x minus 1. The x minus 1 part will be cancelled. What's remaining is only x minus 2. Now if I put 1 in place of x here, it will be 1 minus 2, which is negative 1. Then to rewrite this function to be continuous, we write it as a piecewise function, like this one. We write the function as a piecewise function. For all the values, it has no problem, it's continuous. Only one causes trouble to it, then we say the function is the same for all the values except x not equal to 1. Then when x is equal to 1, to make limit equal to function, we put the negative 1 here. Then the result is negative 1 if x is equal to 1. This way, the limit and the function at 1 are equal, then the function will be continuous. Then since the function was discontinuous in the beginning, now after simplification it's continuous, then we say the discontinuity point is removable. We removed it. Here are some exercise. For x equal to, for this one, c equal to 3. At 3, this graph, it's a straight line. It has no problem. The result is 1 at 3. Then it is continuous. This cubic function at negative 2. At negative 2, the graph is continuous. It has no problem. The result is also negative 2. The limit is negative 2. It has no problem. Let's show this. If I get close to negative 2 on both sides, on the graph, on both sides, it's getting closer to negative 2. Since the limit exists and the value of the function, when x is negative 2, y is negative 2 as well, the limit and the value of the function are both equal, then it is continuous. And obviously you can see that it's continuous, it has no problem. Here, it's not continuous. The limit, if I get close to 3, the limit is equal to 0. Limit x tends to 3 for this function, the result is 0. Why 0? Because it's on x-axis, and on x-axis result is 0. Result means y. The limit is 0, but the value of the function when x is 3, value of the function is 1. F of 3 is equal to 1. Since limit and f are not equal, then this function is not continuous. This one, the function is not continuous at this point when x is negative 2. It's not continuous, although the limit exists, but it's not continuous. And the reason is the value and the limit are not equal. The limit will be 2. The value is 3. It's given. Then 2 is not equal to 3. It's not continuous. This one, the graph is broken. It's directly not continuous. And this one, directly not continuous. These two questions are important. The key of these questions are this. The function has no point of discontinuity. It means the function is continuous. If the function is continuous, it means the three conditions work. The function exists at 2. The limit exists. The function and the limit are equal. Then, since they are equal, let's do this in an easy way. We only write, since it's about 2, then we work on 2. At all the other values, the function is continuous. It has no problem. If there is a discontinuity point, it should be at 2. And the question says it's not discontinuous, means it's continuous everywhere. Then this means if I put 2 here or here, the two results will be the same. Now 2 power 3 should be equal to 8 times 2 power 2. 2 power 3 is 8, equal to 8 times 2 power 2 is 4. So divide both sides by 4, we get the value of A is 2. And it's obvious. 2 times 4 is 8, so A is 2. For this question 18, since there are two missing terms, there is A, there is B, both missing. Then we relate one of them to the upper part, we relate one of them to the lower part. We will have two equations to solve. Now, it's about -1. This is related to -1. Then 2 should be equal to A times -1 plus B. That's one equation. And these two are related to 3. -2 is equal to A times 3 plus B. Now by simplifying these two equations, I can solve this simultaneously. I can get the value of A and B. Here if I simplify, 2 is equal to -A plus B. There is no difference if you write -A plus B equal to 2 or 2 is equal to -A plus B. There is no difference between them. Then here if I want to make B the subject, A goes to the other side. Then 2 plus A is equal to B. I will put this in the other equation. Before I do this, let's do this multiplication. -2 equal to 3A plus B. And instead of B, we have 2 plus A. So -2 equal to, and instead of B, 2 plus A, that's the 3A, the same thing, plus 2 plus A. Since they are both positive, it's okay, but if they are negative, or if this is negative, it's better to use brackets. Now 3A plus A is 4A. 2 goes to the other side, become negative, that's -4. Then divide 4, -1 is equal to A, or A is equal to -1. If A is -1, if I put -1 here, I'll get B. Then 2 minus 1 is B. This makes B to be equal to 1. I get the value of A, -1. I get the value of B, 1. Then this is the answer of the question. Why we are so sure to set these as equal? Because the question itself says there is no discontinuity point, means the function is continuous. Then this is the idea. Application of intermediate value theorem. Intermediate value theorem is important most of the years. It has a question, 2 marks, and it's too easy. IVT means intermediate value theorem. Then use intermediate value theorem to prove that fx equal to 0, where fx is x cubed plus 2x minus 1, has a root between 0 and 1. The main idea is to once put 0 in place of x inside f, write the result. Once put 1 inside f in place of x, write the result. If the two results have opposite signs. Like if one of them is negative, one of them is positive, then we say yes, there is a root because 0 is located between negative, positive. Then if one answer is negative, one is positive, then we just answer this by yes, there is a root between 0 and 1 for this function. Now if I put 1 in place of x here, it will be 1 power 3, 1. 2 times 1, that's 2 together is 3. 3 minus 1 is 2. What's really important is the sign. This is positive. If I put 0 in place of x, it will be 0 plus 0 minus 1, that's minus 1, negative. Since the two answers, one of them is negative, one of them is positive, then we write yes, there is a root between 0 and 1 for this function. There is a root or there is a solution, because 0 is also located between positive and negative. This is the end of this session. Thank you so much for watching. Stay tuned to see the rest of the book.